Hey, in this video, we are going to start talking about probability. And there's probably going to be a lot of fast forwarding in this video because this is literally called basic probability and it's probably the stuff you already know. It will get trickier as we go on. But I did want to take a little time to talk about some of the just basic calculator functions. Again, I'm not really going to go slow through this because I think that most of you know most of this. So let's see what we have. Oops, share. Okay. There's really just like one main thing that I'm going to just drill home, but we'll get to that when we get there. So first step, we're going to change a frequency distribution into a probability distribution. And we've already done this before because look at the steps. Count the total number of observations, which is the sum of the frequency, and then divide by the sum. We did this before, we called it relative frequency. So this is nothing new. I just wanted to come back and remind everyone how to do it now that we've had some time with this new calculator. So I'm trying this display right here because it shows the screen a little bigger and you can still see what buttons I push and I don't have to toggle back and forth. Every video is something new and exciting. Okay, so we are on calculation. That gets us here. I'm just gonna add up these numbers right here. So you can just type them in. Oops, I forgot my plus sign. Okay. 9 plus 16 plus 10 plus 4 plus 1. And then I hit execute or enter, and I get 40. So for this problem, I have, I'm trying to get my text box here. Here we go. A total of 40 in this column. And so for the probability, I'm going to start off, and I'm going to do it both ways at first because I want you to see how to do it both ways, but it's going to be a pain for me to type these as a fraction every time. So I'll probably just do a couple fractions and mostly type in the decimals, but I'll show you how to do both ways. All right, so the first one we have 9 over 40. Oops. Over 40. So then I'll just put my little fraction bar in there, 9 over 40. And some people know that that's reduced, and some people don't know if it's reduced. So one quick and easy way to check is you go to your calculator and do 9. You just hit divided by, and it puts the numerator up top, and we get 40. So we have 9 over 40, hit enter, and it just gives you a decimal. And then you might say to yourself, well, how do I know if it's reduced or not? Okay, put a pin in that. I will come back to that on line 2. So here we have, it doesn't say what to round to, so I'm just going to do this both ways so we have practice both ways. Okay, so the second fraction, 16 over 40, they're all going to be over 40. And as you can see already, this is getting kind of messy because my box isn't that big and my font is. So here we have 16 over 40. This one does reduce. And again, if you know or if you don't know, that's fine. We'll just put it in a calculator. And so when I type in 16 and then divided by, puts that fraction in the bottom, 40, and I hit enter, notice it gives me a fraction and a decimal. So if it doesn't give you a fraction, it can't be reduced. And if it does give you a fraction, then it can be reduced. And this is important because I looked at the homework and everything that is a fraction wants a reduced answer. So we have equals, and then we have 2 over 5, and my fraction bar. So that was 2 different fraction, oh gosh, get my fraction bar. Again, I'm just going to do those 2 because it's such a pain to type in. And then I have my decimal, which is 0.4. Okay, so then I'm just going to continue 10 over 40. And my reduced fraction and my decimal, 4 over 40. And any of these that you, oops, on the wrong screen. Any of these that you already know, you're welcome to just do in your head. Okay, I don't know what's going on. Here we go. 4 over 40. 0.1, 1/10. And last but not least, 1 over 40. So we're just taking the number in the frequency column, we're dividing it by 40, and I get 0.1. 0, 2, 5. Okay, that's it. We've done this before. We just called it something different. I'm just refreshing your memory because that was way back at the beginning of chapter 2, before the test, and so forth. Okay, so let me dump all of this and dump. Yes. Oh man, it does not want me to dump stuff. What in the? Oh gosh. Now I made it mad. Huh. Oh, because those aren't drawings, they're typing. You know what? I'm gonna pause it, and then when you come back, all gonna be good. Okay, perfect. Oh, wrong pause. Okay, I can't find the pause button. Cool. So let me just scroll down and see what happens. Maybe it'll just go away. Scroll down. Oh, okay. No problem. It just went away. Okay. Number 2, we have a problem right here. And what I'm going to do, oh gosh, now I paused the wrong thing. Okay. Are we all together on the same spot? I'm pretty sure we are. Wow. Okay. So for this problem, what we're going to do is we are going to add up everything. So it's the same problem. It's just written in a different way. The other one was written, in columns, and then this one's written in rows. The point is that it doesn't matter. Okay. So, okay. I'm just having fun with buttons today, aren't I? I'll stop clicking. Okay, so here we have this problem. So I guess what I first have to do is add everything up. So I'm going to go to my calculator and I'm going to hit 941. That's fine. 941 plus 1349 plus 703 plus 178 plus 67 plus 21. And so I have 3,259. I just like to write the total at the end so we know. These are not going to be pretty fractions, so this is just going to be all decimals. And I'm probably just going to round it a little bit just because it's not going to probably fit in this box. So let's just see what this first one does. So we have 941 over 3259. Oh yeah, that's a mess. So let's just go to 3 decimal places. 0.228. Nope, 229, because that. Remember when I said this is going to be an easy video? It's because it is, and so I didn't really prepare for it because I know you already know this stuff, and now I just keep talking over myself. Okay, 0.28, and then this 8 rounds up to become 9. Voila. Next step, 1349 divided by 3259. To 3 decimal places, it cuts off at the 3, the 9 tells it to round up, so we have 0.41. This is the last one we're going to do, and then we'll move on to a different topic. Okay, 703 divided by 3259 cuts off at the 5. The 7 tells me to round up, so I have 0.216. Again, feel free to fast forward to the end of this if you know what you're doing, and you will just see all the answers. You can just do it yourself and then double check the answers. 0.055 because the 6 tells it to round up. 67 divided by 3259. 0.021 because the 5 tells it to round up. And last but not least, 21 divided by 3259, and we get 0.006 because the 4 says leave it alone. And so from here, we can see the probability of a household having 5 pets is 0.006, very small probability. The highest probability is that people have a household has 1 pet, because that was 0.414 or 41.4%. Okay, so let's talk about properties of a probability distribution. These are very important. These are going to come up time and time again. I don't know where my mouse button is. Okay. There we go. Properties of a probability distribution. There's 2 main properties. They will come up. throughout the rest of this class. So there's two things. First, each probability must be between 0 and 1. And so what that means is no negatives, because if it was negative, it wouldn't be bigger than 0, and also less than or equal to 1. It could be equal to 1, that's fine. It could be equal to 0, that's fine. It can't be greater than 1, because greater than 1 as a probability means more than 100%, and we can't have that. And less than 0 means a negative percent, and we can't have that. So it's just from 0 to 100%, or as decimals, 0 to 1. Number 2, the sum of all the probabilities is 1. So when we add everything up, it equals 1. So if we went back here, I'm not going to do it, but just to show you, if I added up all these numbers here, it would equal 1. If I added up all these numbers here, it would equal 1. So the sum of all probabilities equals 1. In this first example, determine whether or not the distribution is a probability distribution, and say if it's why or why not. Okay, so right off the bat, we can see that we have a negative right here. Oh, negative right there, which is a problem. And so this is not a distribution because we have something that's less than 0. So the less than 0 part is the part that messed up this, the negative. The negative is really easy to see. And so since I have that, I can mark that one quickly. Now, it might not be a probability distribution because of this. Well, we know it's not probability distribution, but it says select all that apply. So I'm going to check the other one. The other one might also be true, and it might not. And so you can just add these up. Some people can just add them up quickly in their head. If you can't, just throw them into your calculator. We have 3/4 plus 1/4 plus negative 1/4 plus 1/4, and it equals 1. So I don't want to put this bottom one because this says it is. It is not. But I can't put this top one that says is not because this one says not equal to 1, which it is. So my point is there's only one answer for this. Sometimes there's two answers. Sometimes there's only one answer. Okay, so then number 2, so that worked with both properties. Number 2 is talking about a news program that reports 46% of the population are in favor of a certain issue and 48% are against an issue. Create a corresponding table. So we have our table, which has 2 columns, or make it have 2 rows, whichever one you want. And so what I'm going to do here is I'm going to put P of X, that's the probability column. And then over here, I'm probably just going to write something vague. It looks like we're asking people for their opinion. It doesn't have to be too fancy, but are you in favor or are you against? So that would be over here. So I have favor, in favor, and then I have against. Line here. Okay, so let's see. Oh, goodness gracious. Okay, in favor, we have 46%. So I'm going to write 0.46 because remember rule number 1? I think it's rule number 1. It doesn't matter the order. But one of the rules says it cannot be greater than 1. So I can't write 46 because that's bigger than 1. I need to write percents as a decimal, so it's 0.46. And then it says against are 0.48. Okay, got my rows, put all the information in. Second rule says it has to add up to 1. And so these are both less than a half. This does not add up to 1. If I am over here and I have 0.46 plus 0.48, I get 0.94. That's like 94 cents. So that means we have one last column, or sorry, row, and that would be something like no opinion or no answer. They just didn't answer the survey. Something along the lines of no opinion, no answer. And so I have, since the top two add up to 94%, I need to have 6% left over. And if you're not sure how to calculate that, just do, we know it has to add up to one whole, so I'm going to subtract the 0.94 to get the 6%. All right, so they're not terribly difficult rules, but they're very important rules, and they come up over and over and over again, not just in this chapter. Okay, basic probability. For basic probability, we are not getting fancy. We are not doing like this and this versus this or this. We're not doing things with replacement, without replacement. We're just doing basic probability because we want to spend more time getting into the fancier probability in chapter 4. So, things you need to know. You need to know what a die is, six-sided die, and you know, like the little cube with the 1 and 2, the dots on it. And you need to know things about a standard deck of playing cards. And so if you don't know those things, go to the dollar store, get some dice, get some cards, play with them this weekend or next weekend or whatever day today is and tomorrow is. And familiarize yourself with those two things. But you do not need to know how to play poker. You do not need to know how to play roulette. You don't need to know how to play any games. You just need to know about a die and a deck of playing cards. So you'll see this the one of these problems, maybe it's on another video, talks about playing roulette. Again, you don't need to know the rules of it. You just need to follow the steps in the problem. But here, it doesn't give you any other information other than you have a six-sided die. And so a six-sided die is has the numbers 1 through 6 on it. So rolling an even number, well, the even numbers on a six-sided die are 2, 4, and 6. There's 3 even numbers over a possible 6 total numbers on the die. So that's what these formulas up top are telling us. They're telling us the total number of ways we get it over the total number of outcomes. And then, of course, we always want to reduce. So we have that equals, and if you don't know it, put it in your calculator, but that equals 1/2. That would be a letter fraction. Okay, rolling an odd number. Well, guess what? There's 3 even numbers and there's 3 odd numbers. So our odd numbers are 1, 3, and 5 on a die. The same 3 out of 6, so we know the answer is going to be 1/2 for this answer as well, because it's even number, odd number, same probability. Okay, last one for the die. I don't know how this thing got here. It won't go away. Okay, rolling a 2. Well, there's only one number that answers that, and that is 2. There's only 1 2 on it. So 1 out of the 6 sides is a 2. And so we have 1/6 that can't be reduced, and that's our final answer. That's it. That's as fancy as we're getting with probability. Okay, so we're going to try this again. This time we have a standard deck of 52 playing cards. As a quick reminder, if you don't know this, then go get a deck of playing cards and play with it. But we have 4 suits, a club, spade, heart, and a diamond. And you have 4 suits, and each suit has the numbers 2 through 10, and then they have Jack, Queen, King, Ace. Okay, so it says, what is the probability that there will be a 6? So the choices, and you could just think this, you don't have to write these down, but there is a 6 of clubs. I'll write the letter because there's only one of each. A 6 of spades, a 6 of hearts, and a 6 of diamonds. There's 4 possible cards. And we know, because it says above, that there's 52 total. So there are 4 out of 52. That's the probability of getting a 6. Come over here. Let's see if that is reduced. 4 out of 52. And I see that it's 1 out of 13. A lot of these probabilities for like this section that we're in right here want fractions. The tables, a lot of times the tables want decimals, but then over here they want fractions. That's kind of the general rule. But if you're not sure, just read the instructions and it will tell you. So we have 1 out of 13 is our reduced answer. I can move that up a little better. That's good. And 1 out of 13. Oh, give me a break. Okay, just imagine a fraction bar right there where we want it the most, right? Okay, forget it. It's imaginary. Okay. The card will be a face card. All right, what is a face card? Well, looking at this list over here, a face card is, oops, I almost got the 8 in there. I don't know. Can I get rid of that? Oh, no. No. Oh gosh, okay. I am undoing, I did all my fraction bars. Okay. Imaginary fraction bars, we can do this. Here we go. Got everything. So this right here, let's go back to what is a face card. Jack, Queen, and King are the face cards. Ace is not a face card. You'll see in part C, ace is an ace. So there's 3. So that means there will be 3 clubs. So we will have, I'm going to write them out real quick. We will have the Jack, Queen, and King of clubs. So there's 3 right there. And then we'll have a Jack, Queen, King of spades, Jack, Queen, King of hearts, Jack, Queen, King of diamonds. So there's 12 cards altogether. So there's 3 clubs, 3 spades, 3 hearts, 3 diamonds. That means we have 12 cards out of our 52 are face cards. What is 12 out of 52? Let's see. 12 out of 52 is 3 out of 13. Equals 3 out of 13. Okay. I'm going to be happy when we are out of this fraction section. Okay, last one. Okay, last one, yay. So it says the City of London in the United Kingdom has an average of 12 rainy days every March. What is the probability that it rains on a March day in London? So when we write probability, I wasn't writing it up above, but we would typically write the probability, and we put like rain in March. And up here, I could have done a little better by writing the probability of a 2, 4, or 6. A probability of 1, 3, and 5. And this one, the probability of a 2. Versus this out here, we have a probability of this right here would be, started off being a probability that we got a 6. And then this was just my notes of how many 6s there were. Okay, probability of rain in March equals, and I lied, there's one more thing you need to know, and I always forget because I always think people just know this, but then when I do my face-to-face class, people apparently don't know this. If you don't know how many days are in each month, when you're at the dollar store this weekend, grab a calendar too. So in March, there are 31 days. So we get 12 over 31. If you put 12 over 30, you might think it reduces, but you are wrong. Well, you're right that it reduces, but you're wrong that that's not the answer. The answer is 12 over 31. Okay. Could I redo this video and be more professional? Totally. Will I? Totally not. So I am going to take a break, get a drink of water, and make another video for you. And hopefully you just fast forwarded through most of this anyways, because you already know how to do probability. Okay, bye.